Hi everyone. I will tell you how to trust an agent with software delivery. First of all, I'm Sam Alba. I spent quite a few years at Docker before, where I built and ran engineering teams. And after that, I co-founded a new company called Dagger. And Dagger is an open source platform that lets you automate anything from build, test, deploying. And about 2 months ago, we introduced the ability to interface with large language models directly in the Dagger API, and which lets you delegate some of those software engineering workflows to AI. And we also started to dock with this ourselves in our software delivery. And so we went through a lot. We learned a lot actually while doing so. And so I wanted to share some of our learnings. First of all, why leveraging agents in software delivery? Well, the very first reason is you might have seen more and more AI generated code in software delivery, and it becomes really a bottleneck to test more and more code. You see a lot more code happening that you need to test, build, and deploy. And also, which increases the load on software engineers to review this code, right? And to benefit from having agents in software delivery. And so agents can help because they can help automate a lot of things that humans need to do. It also helps you manage more complex automation. And the goal is always the same in software delivery, is about velocity. It's about shipping faster and more often. And so some of the examples of those agentic workflows is, for instance, some small agents that are very task specific. For instance, showing some examples here, like optimizing Docker files. We shared an examples of that in our docs, or generating unit tests or review pull requests, basically adding comments that software engineers can then review instead of having to read all of everything from scratch. You can actually rely on agents to point to specific areas that you need to care about more than others. And also we started to experiment with coding agents. So you might have heard about Codex or Claude, and they can help you implement some simple features that some more junior engineers could do, but they also can assist everyone really in the PR review process. Yeah, we started to experiment with those with a lot of, I would say, mixed feedback. We had some really great results and some results that are not that great. And so I'm going to share some of the learnings. So first of all, how we think of AI agents when we start. So this is where you start, basically. You might think of giving a very simple set of instructions, something very clear. Hey, I want this wooden stool. And so I needed to, fit those criteria, and that's it. And so you submit your instructions, your prompt, and then behind you have a fleet of agents that happily collaborate, each focusing on one specific task of the process. And they come back with a result that's always exactly what you wanted. Right. Well, as a matter of fact, it looks more like that. So it's chaotic because, first of all, the accuracy is not always great. Sometimes it's good, sometimes it's not, sometimes it's useless. And when you notice those problems, you start spending a lot of time tuning your prompts. And also, each agent has its own set of tools depending on what they do. And so you'll see that tools are basically functions that you wrote, that you expose to models, and the model calls only when needed. And this logic of calling the tools is really opaque and not always the same. And so when you face those problems, and you will face those problems, probably you're already facing those problems, you need to start investing in evals. And evals is really the CI of your agent. So I will share a little bit more about evals, but the TLDR is that evals cause more retries, which consumes more tokens, which ends up costing money, basically. And so I'm going to share with you some lessons learned, so you can avoid some of the mistakes we made, and giving you some tips on which you need to focus on. The first thing is, it's important to scope agents to a small task, and a small task that is well defined. So usually a broader scope for an agent means sometimes a smaller prompt. So when you say, for instance, an example would be, you're an experienced software engineer, I will give you task and you need to give me what I ask for. That's a very small prompt. That's open-ended. The scope is super large, but the prompt is super small. You need to do the opposite. So basically, a well-defined task means a smaller scope with a larger prompt, a long set of instructions with some guardrails, with some things you need to avoid, with some examples of what I'd like to see. And also, it's a lot about the context that you give to the model. And part of this context is the list of tools. So those functions that you give to the agent. Ideally, you need to limit it to a minimal set. And so the smaller set of functions you'll give to the agents, the more accuracy you'll get. And oftentimes when you look at this list of functions, you realize that the agent actually might not need that. And you might instead call those functions from outside the agent loop. Outside of the agent itself, basically in another part of your workflow. And a good example of some smaller task is this Dockerfile optimizer that I shared before, but it can also be part of a bigger agent, right? And so this bigger agent is better if it's actually a fleet. So you have a simple agent with a simple prompt at the beginning that actually route to sub-agents what needs to be done. And each agent in that fleet is actually focused on a very simple task with a large, well-defined prompt and possibly accessing a smaller models. Another lesson is agents need repeatable sandbox. So exactly like software engineers, you don't want to let everyone in the development team access privileged environments. And so the same thing for agents. And ideally, the sandbox can be the same for software engineers and the agent. And in that sandbox, you really need the ability to manage the state because an agent needs to start from a clean state, right? When you call an agent several times, you need to make sure that the state it starts with is always the same. And you also need the ability to import and export the state depending on what's the input of the agent and what's the output. In the case of the Dockerfile optimizer, that could be a repository of code, and the output might be, I don't know, a commit or another repository that you will use later on in your code. And that sandbox need is actually the reason we added the LLM support in the Dagger API in the first place, because we couldn't find a good solution for giving container access, a nice container API to models. And so that we ended up building our own and giving it to all the Dagger users. The third thing is it's about observability. So if you want to trust agents, you need to know what's going on, right? What's going on in this agent loop while calling tools, either during the runtime and following live what's going on, because that could be it could be long workflows, right? And also after the fact. So if something happened and you're not happy with the result, you need to be able to go check a workflow run and investigate what happened. And realize that most of the tracing solutions on the market right now that are AI focused are really linked to a model provider. So for instance, OpenAI has one, Anthropic has another, Google as well. And ideally, you want the same, what we call a combined tracing. You want the same tracing that you use for all of your workflows and make it LLM aware. And the last thing is, well, you need to break this 70% accuracy, right? And so this is when evals come in. And so evals stand for evaluations, so model evaluations. We think about evals-driven development. So it's a term that you might have heard before. It's very important because in order to know the success rate of your agent, you need to implement evals in the first place. And so it's not only needed for measuring the accuracy of your prompt and tuning it along the way, but also see how the model performs, as it evolves, as it moves to newer versions. And also if you want to try out the same prompt on several models and see how it performs. And also how the model calls the tools. So what we call the tools calling scheme. So it's very important to assess the performance and how it works, and especially how it works over time after several retries and several versions. Those evals actually becomes expensive quickly because you need to call models several times. And so really quickly, you'll think about using smaller models that are also faster and cheaper, but they're also less capable, which means that you need to design your prompts for those smaller models. This is exactly where you will get the best results. You should even consider giving your local models a try. So in our team, we have some people using models locally just because it's completely disconnected from model providers. And another lesson is, it's not written here, but it's basically there is no escape outside of prompt engineering. A lot of the work needed for running evals correctly is about prompt engineering. So it's really important to understand how models process the prompt, how they behave, why each model provider will behave differently depending on the instructions you will give. And finally, a quick recap of what we provide at Dagger. So Dagger is an open source platform. You can use it for free, lets you build software engineering workflows. And it also provides the containerized sandboxes for your agents and any workflow. And we also provide full observability. Yeah, thanks for listening.